Hey guys, I'm going to give you a quick tutorial here on how to use iterators inside of Quartz Composer. So what iterators are, or they act like for loops, meaning that whatever code is inside of them will repeat themselves to a specified number of times. So I've already created a blank composition and I have an iterator here on stage that I found inside the library. You can type in iterator and it will then appear on your screen when you click on it. But when I inspect the iterator, you can see that it has iterations listed here, and this number can be changed to whatever we want. By default, it'll show up as 10, so we can change this as we want to, and I'll show you later on how that works. But first, we're going to explore how to use iterators by scattering sprites across the screen. Okay, so I want you to watch right here where it says root macro patch, because this is a patch navigator. So if I double click on this iterator, and if you notice that it's black, means that I can double click and go inside of it. Okay, so we're now inside the iterator and we're going to add a sprite and a few other things to make this look interesting. So there's a sprite, okay, and I'm going to just inspect the sprite really quick because right now it's at full size. I'm going to make it a quarter of the size by going 0.25. Because 1 equals 100% inside of Quartz, 0.25 will be 25%. And then I'm going to change the color to half opacity so that way we can see through some of these when we scatter them across the stage. So if you notice, the positions and the rotations are all set to 0. So if I were to view this right now, you can see I just have what looks like one square in the space. But in actuality, I really have 10. Because they're stacked up on top of one another and the opacity is at half, it just looks like one white square. So we're going to now play with scattering shapes across the screen so that way we can make this really work to our advantage. So what I need to do here is I'm going to connect to something called iterator variables. Now this is a really powerful thing when we're using iterators because it gives us information about the iterator we're working within so that way we can target specific objects right when we're working in the space. All right, and if you notice there's three things: current index, current position, and then iterations, okay, which we saw earlier on the outside of the patch. So what we're going to do first is we need to randomize the position. So I'm going to use a special patch called noise. Now I'm using this one as opposed to random itself because random animates, right? It's a time-based number generator, and noise is an instance-based number generator. So it's going to just work once, which is what we really want. So I'm going to drag two noises onto the stage and we're going to change things up here a little bit because we want to target the X and Y position. Now for some reason we have to use two noise patches in order to make this work, but we're going to tweak these right now so that way we can get one value of X through here and one value of Y through this one. So if I inspect the noise patch, what I can do is click through and change the number of dimensions to 1. And I'm just doing this for the X, but I'm going to leave this noise patch to have 2 because we're only going to use the Y. So what I can do right now is I can go to where it says current index. Now current index acts as a counter. So as you can see here, it tells us current iteration index 0 to count -1. And what that means is that if we have 10 iterations, that really the index goes from 0 to 9. Okay? So I'm going to attach this to X and then the result to X position of this sprite. And now this patch here will affect the sprites, all of them, and give them a unique position. Okay, and I'm going to do the same thing for Y here, and we'll go result to X position. Now immediately I can click the viewer, and you can see I've got shapes scattered in a nice little location there. And because we're at 50% opacity, we can see through them. All right, so we now know this works, which is great. But they're all stuck in this sort of realm of the screen, right? And as if we know, 0 is right here in the center. This is +1, and then, or sorry, opposite. This is -1. This is +1. -1 here, and then +1 to the right. Okay, so it works in a Cartesian fashion, right? Like you studied in geometry in high school. Good times. So now back to this. We're going to massage the numbers a little bit, so that way we can have shapes go all over the screen. And I'm just going to unhook X and Y position here real quick just by dragging them off. And I'm going to use our friend math to add a way to make the numbers span more evenly across the stage. So what we're going to do is we're going to connect our result to that top input. Same thing on this side. And then I'm just going to connect this to X position and then this to Y position. Okay, I'm going to get this just aligned here so we can see a little bit better. And we have to add now a number to work with, so I'm going to double click on the bottom input and I'm going to say 0.5, all right, and I'm going to make this minus by 0.5. Now this is just one method. You can try different methods like multiplication times negatives works well, but just to get started for us, we're just going to change this up just so we can see a nice result. Okay, so negative 0.5 is going to sort of put things not at the edges but more in the center. So if we now go back to the viewer, you can see that things are laid out a little bit more evenly. Okay, and let me just double check here. Yep. Yep. Okay. All right. So it seems like this round of random is just kind of basically interesting. But what we're going to do right now is we're going to now apply with the something called an LFO, which is a wave generator. We're going to make these shapes sort of dance but hold their current positions. Okay. So what I'm going to do is I'm going to now add a LFO, which is a wave generator. So I can just type LFO into the library, and there it is, wave generator. And I'm going to now connect the result to the Z rotation of the sprite. Okay, and if you can see, when I roll over that section, I'm getting now some numbers. But because rotation is on a degree scale, we need to go from 0 to 360. As you can see, this number value is very low. It doesn't even break 1, in fact. So if we take a quick view, you can see these things are just basically gyrating between 0 and 1 degree, which isn't very interesting. And they're all moving at the same rate. So what we're going to do is we're going to connect here the... Oh, also, okay, I'm seeing now why I'm having a problem. I need to make sure that this is connected from current index, not current position. That's a little bit misleading here, and you can see I've got much more even distribution. Okay, I was wondering why that was looking strange. All right, so make sure current index is connected to both X and Y, and you have negative or minus 0.5 on both of your mathematic patches, and they're connecting all right. And now let's resume with the wave generator. So I'm going to take current index as well, and I'm going to connect this right now to, let's try Amplitude, all right? And I'm going to inspect the wave generator just to see what I have going on in here. So I have a sine wave. The period is 1, which is very short. I'm going to make this 15, okay? And the amplitude right now is set to 9, okay? Which on a degree scale isn't much. So we can see here what we have is we're rotating now in between 0 and 9 degrees. Again, not very exciting. Okay, so what we're going to do is we're going to unhook amplitude, all right, and we're going to reconnect this to offset. All right, so offset's a nice way to sort of variate within the wave generator, and I'm going to re-inspect that. So you can see now I have an offset of 9. Okay, so per value we'll have an offset of 9 degrees, which will be cool. And then amplitude now we're going to make 360. All right, just hit return to set that up. And now what we get is our shapes are moving at slightly different rates. Okay, the period is set to 15. And let's see, there might be some other numbers in here we can play with that'll give us some interesting values. All right, so because I have solid numbers here, let me set phase back to 0 here. All right, because we have just one iterative value flowing into offset, we're going to now grab a second value, all right, and we're going to play with that in terms of, let's try period. Let's see what happens here. So I'm going to grab a second chord and connect that to period, which will change the time frame, and we'll go back to the viewer, and here we go. All right, we've got some crazy, wacky, changing squares, which is a lot of fun, all at different rates. So we can see that with the iterator, we can just make one sprite, and we can control 10 of them based on how many iterations we make. So as I mentioned before, we can go back to the parent, all right, and we can now see the iterator changes blue, meaning that it has stuff inside of it. Now when it changes blue, it does that specifically because we have a sprite. And a sprite is a display object. So that's the reason it's changed. So now with the viewer up, watch what happens. If I inspect, the iterator itself, all right, I can now start to add iterations, right? And as I add more and more and more and more and more, they're all going to take on unique behaviors that I've added inside of the patch. Okay, so as you can see, I'm getting multiple bits of information, and nice, I have this 68 iterative sprite animation that's now behaving at sort of all different rates and speeds. Now, with an animation like this, it's interesting that I have different rotations. But let me jump back inside real quick, and let's just sort of play with size. Okay, so because I'm using a sprite, I can play with width and height. So I'm going to add another noise value. Okay, so now noise, as you can see, works with, I just copy and pasted that, by the way, with just singular values, which is cool. So X can be sort of be translated into other things. Okay, so if I now go to current index and I connect, I now know that that's going to be 68. So this is going to have a variant size of 68. Of course, with math, I can change the way that works. So with result, I'm going to go to where it says now width. All right, and let's see what we get here. So because I just changed the width, I've now got all sorts of different shapes and sizes. All right, some real sort of little skinny ones and some bigger ones. All right, I'm going to just quickly go up and, well, in fact, I'm just going to inspect the sprite here real quick, and I'm going to lower the opacity to be less than 50 and make it like something really low, like 10. 10's a good number. Okay, so now we can see through much more of these, right, as we bring them up. So let's bring up the viewer. All right, and you can see it actually improved our frame rate, but still there's a lot of them. So maybe if I lower the iteration value, we can see that there will be many less. All right, and these are these circular sort of things. Okay, so that's 25, which is pretty cool. And my last thing here is I'm going to just go back to my patch, and I'm going to now add a second value of noise, or a second patch, I should say. And it can be the same kind with just X. And I can go down, kablam, connect that, and then I'll now adjust the height and back to the viewer. Okay, and now I get all sorts of crazy different shapes and all sorts of things. Now if I want this to be uniform in size, because noise is always going to be random, I can just grab the result, the second result, and connect that to the height from the previous noise generator that I made. Okay, and now you can see I've got squares again. All right, I'll just lower the amount of iterations here. And now I've got random rotation, random speed of rotation, random location, and now random size, okay, which is pretty cool. So this is just a getting started approach to this, working with iterators. Okay, you can see this is all I've built. Let me go back now, and here is the iterator that I've set up itself. If you want to feel saucy, you can copy and even paste this iterator, and you'll now get double the amount. But unfortunately, the values are duplicated, so that trick doesn't really work. And this is just a good getting started, so I'm interested to see what you guys make, and I hope this helped.